Welcome students. Today is the 23rd lecture on digital land surveying and mapping. In today's lecture I will discuss on how to measure horizontal angle using total station, and this lecture will be discussed under the following heads. First I will introduce, then the measurement of horizontal angle, how a total station provides us the horizontal angle, that I will tell you. Then different methods that we make use to measure the horizontal angle. One is method of repetition, another is iteration. So I will discuss that and followed by demonstration for each method. Now horizontal angles are measured in a horizontal plane. So we have to make this total station properly adjusted before taking any measurement of horizontal angle. So proper adjustment means, already we have discussed, to make the instrument first approximate leveling, then fine leveling along with centering, and followed by the sighting of the object. So that is to be done before we go for any horizontal angle measurement. Now before I really go about the measurement, how really this instrument provides us the horizontal angle, that I would like to discuss. Actually, as I already told, that in this instrument there is a pair of horizontal plates, or these plates become horizontal, perfectly horizontal, when we make the instrument level. So we need to make this instrument level, because horizontal angle is to be measured in a horizontal plane. Now these two circles, actually there are two circular planes, circles, one placed above the other, and one of these circle, the lower one rotates and upper one remains static. So the lower circular plate is called rotor, and the upper circular plate is called stator. And one more point, this lower circular plate is having some equally divided alternate dark lines and light spaces, and upper plate or upper circle contains slit shaped patterns which has the same pitch as that of rotor circle. Now actually these divisions actually provides us the precision of measurement of angles using this instrument. So the more precise these divisions are, better precise angle we will be able to measure. Now what happens whenever we place this instrument properly leveled, then the horizontal plates, both the plates which are one placed above the other having a small space between them, they become horizontal, and then when we will bisect the objects and we will find out the we will like to find out the horizontal angle, then this one plate will move with respect to other, and light will be passed through horizontal plates, and thus there will be creating alternating variations in light intensity, and from the below their light will be passed, and in the above there is a photo detector. That photo detector detects the signal and the intensity, and that photo detector then converts this light to electric pulse, and this passes to the microprocessor, converting the amount of energy to corresponding digital values, and this digit and then converted to angle. So this is the basic arrangement that is made in this instrument, which provides us the measurement of horizontal angle automatically whenever we rotate from one by a point object to another object. And finally this value is displayed in this LCD. So this is the basic how automatically we do measure the horizontal angle using total station. Now to measure the horizontal angle, what we need to do, as I have already told, that before making any measurement using this instrument should be done properly. That means we should do the centering, leveling as well as bisecting the object nicely, very accurately before the measurement of horizontal angle. Now suppose there are two objects, A or two targets. We have two targets between A and B whose angle with reference to our instrument station O. Now our instrument is set up on the station O. We want to find out the horizontal angle between A and B with O as the instrument location. That means we want to find out the angle AOB. So what we need to do, first we have to set up our instrument, set up total station at O, and then we set up includes the centering and leveling of the instrument has to be done on perfectly on O, location O. Then what we will do, we will first bisect, we will make this object bisected, bisect O, A from O. Now once this has been done by using the telescope, we should first make use of the lower or horizontal circle main screw and main and tangent screw to perfectly bisect this object O. As we make it perfectly bisected, then we will, whatever reading will be displayed, we will make it 0. Now after doing that, we will open the main horizontal screw, and then we will look to object B, and by making use of the lower horizontal circle main and tangent screw, again we will bisect this object B. So as soon as we will bisect the object B, the display, LCD display will display the horizontal angle. Now here you have to keep it in mind that the angle is measured always rotating the telescope in the clockwise direction, that is towards the right of the observer. So this is another point which has to be kept in mind. So in this figure you see this is the station O, and we have placed our instrument. This is the location of the telescope, and first we have to bisect the object P. We have to make the horizontal circle reading 0, then we have to bisect the object Q, and then we will get the horizontal angle, and horizontal angle will be in a horizontal plane. So the horizontal angle between POQ will be the P dash O dash Q dash or P double dash O Q dash. That will be the horizontal angle between the object P and O with station O. So in taking the horizontal angle between two objects, we should take the back side to the left object, and we should take the foreside to the right object. So that is another point we should note down it. So now I will like to demonstrate this phenomena using this total station. So as I told you that this instrument has to be first properly leveled and centered. So we will do the centering and leveling first. So now to as I told you in our previous class, to make the centering and leveling, first we have to make it approximately centered and level. The approximate centering and level of this instrument has to be done by making use of the tripod stand, and whether it is approximately level and centered or not, that we have to verify. We can verify by looking into the circular bubble here. If the circular bubble is at the center, that means it is approximately level. Then we have to look through this optical plummet to see whether our instrument is exactly on the top of the centered or not. Now if there is any mistake or any, then we can open this one and we can shift the instrument. We can shift the instrument, and by shifting the instrument we can center it. So that is what approximately centered and level. After doing this, we have to make the power on. If we make the power on, then our instrument will be on. So now we using this, now we have to take this our data collector parallel to this, and more or less this is in the center. So third one, you can see this one. If there is a blue, that means this labeling is okay, which we can carry forward. I want to show one more thing. Now suppose it is like that. Now you can see that this is our centering and labeling is disturbed here with red sign. That means it is not properly done. So we have to do till it becomes blue. So every instrument there will be some information indication like that. So because it is blue, so we can go for it. So once it is centered and level, now it is in blue, so it is centered and level. Now I can go for measurement of horizontal angle. Now to measure the horizontal angle, so now first I will like to take the horizontal angle between reflector, keeping here and somewhere here. So to make our work easy to see, and first I have bisected this by looking using this horizontal plate main screw or the lower plate main screw and the vertical plate main screw. I have oriented my telescope towards this, and then approximately I had focused the object. Then using fine tangent screws I have brought the center of the reticule. So I have a reticle center like this, and the prism having this some center like this. So to this center I have bisected this center. Now I will make the I have brought the main menu, observe, and for this, because it is the first object, so I will like to set this line as 0 0, so 0 set. So if I make it, now you can see that the horizontal angle is 0. Actually there is an error of 0.56 second here, so sometimes there is some error, so that can be taken care of by noting it down. So it is 0 degree now, 0 degree. Now I will take the horizontal reading between this angle and some, keep this someone this. So now it is 0 0 line. So now I will open the lower plate main screw, and I will rotate this instrument in the to my right, pointing to this prism. So now I will fix the lower plate main screw and look through this. Now I can see the object, so I can make use of fine adjustment screw. Now I have perfectly bisected it, and now you can see there is a reading 92 degree 49 minute 40. So this angle is 92 degree 49 minute 42 second, and there is a error of 6 seconds. So I can say that the angle is 92 degree 49 minute 48 second. Now here you can see the measurement of angles are done automatically. We need not go for any measurement, or as we did in case of slope distance measurement, we had to press the key menu measurement, but in case of horizontal angle measurement the instrument provides us automatically this angle. So angle is measured. Already you have seen that there is some error of 6 seconds. So initially to make it 0, and then we can simply add it. However, there may be some other errors associated with this instrument in setting up the instrument as well as inside the instrument. So in order to avoid that errors or minimize the error, as well as if we want to increase the precision of measurement, so we do carry out the measurement of horizontal angle by a method called method of repetition. By repetition method for horizontal angle measurement. By the name itself you can understand repetition means here method means repetition. We will repeat the measurement of horizontal angle of the same angle number of times. So if we measure the same angle, suppose AOB, add it n numbers of times, we will get a value which will be divided by n, we will get the we will say that is the angle value of the angle. So now in repetition method actually there are two ways we can do. In each repetition method there are two steps. One is to measure in normal mode and other n times, and also measure in reverse mode again another n times. So whatever value we will get finally, that has to be divided by 2n, angle AOB will be 2n. So now what is normal mode and reverse mode? Normal mode is that measurement whenever we will make use of the instrument, if we maintain this is the vertical circle to the left of the observer, that is called in normal mode, and reverse mode is that by making this horizontal angle, so if we by rotating the telescope by 180 degree and then about its horizontal axis and again 180 degree in the vertical axis, we will have this arrangement, and that is called reverse mode. So we can take the measurement also in reverse mode, and once we if the instrument is to be used in reverse mode, then we need to have the data collector on both sides. In this instrument only one side we have the data collector, so it is not preferable to go for plunging or the reversing of this here. Anyway, so this is the normal mode which I am keeping. So now I can demonstrate you also the measurement of horizontal angle by method of repetition, keeping the instrument in normal mode. Again for the same normal mode, first we have to set up the instrument, and we have to make our temporary adjustment of the instrument as we did in case of measurement of instrument. So let us assume already it is centered. So let us assume that the centering and leveling has been done properly with this. Now to carry out repetition again, first we have to for the method of measurement, first we have to bisect this object and we will make it 0. We have make it 0. So after make it 0, we will open the lower plate circular screw and then we will look to this and we will bisect the object. Now we got some angle. Now what we have to do now in this, we will go to this is phase 1, we will go to the phase 2 and note down this angle 96 degree 27 minute 11 second. Now I will take this, we will set here and 97.26. Okay. Now I have bisected it and then again I will open this, then again I will bisect it. So now I am getting the approximately double the angle which has been read. So in that way I can go on repeating it. Actually in the field we need to have more numbers of targets so that we can make use of the same target. We need not shift the targets. So in that way we can measure the method of repetition. So that is what it is written, these steps. So the main thing here it is that horizontal set. For the second point, whatever angle we will observe, that has to be set through edge set menu, and the first object again has to be targeted and then with horizontal set next angle we can see. In that way we can repeat in numbers of time and we will get the summation of the angle in this, and the divided by the number of repetition we will get the average value of the angle, that is the angle value. Now another method which we do generally apply for measurement of horizontal angle, that is the method of retardation method for horizontal angle measurement. So what it is, generally if from a same station we want to find out the position angle between a number of objects, suppose P, Q, R, S, and we want to know what is the angle POQ, QOR, ROS. So this angle, if we want to know what is the angle, this is the angle, then we make use of method of iteration. What we do, first we bisect the object P and make the 0 set, and then we will rotate the telescope in the right hand and bisect the object Q, and we will get some value, and that value here we can set H set, and then from that value we can measure this value, so we will get this value, and then again whatever value we are getting here we can set it and from there we can then, in that way we can go on adding, and finally we can close it, and by closing it we will get we must get 360 degree. So that is a check. So that is method of iteration. This is another method of measurement of horizontal angle. So you can see, using total station the measurement of horizontal angle can be done automatically. With this I like to conclude today's discussion on horizontal angle. Here we have found that the horizontal angle is measured in a horizontal plane. So the prerequisite condition to measure horizontal angle using a total station is to make it properly leveled and centered, and then our target should be proper. That means if the target is not visible or we are not able to see properly, then the angle measurement will be not proper. And to improve the precision as well as to minimize the error, we should go for the method of repetition. And when there is a condition where we will like to measure a number of horizontal angle from the same station, then we will go for the method of iteration. With this I like to conclude today's class, and the next class we will discuss on a measurement of vertical angle and how to measure the height as well as difference in height using total station. Thank you.